So today's video is working on the fuel pressure regulator. The idea here is I'm trying to test all the various systems of the engine because since I have no idea of the status of the engine and the fuel injection and how all it's going to work, I want to at least eliminate as many variables as possible. So the first variable we eliminated was getting a fuel pump to work to get fuel. That works. The second variable we get rid of was, do the injectors actually control the fuel flow? Well, we know it can turn them off. I don't know if they'll turn the fuel on, but I know for sure it'll stop the fuel now. You know, we had a little problem with the flange cylinder. We all remember that one. So that's been addressed. The next question is, can the fuel pressure regulator control the pressure based on the vacuum it sees or the pressure it sees inside the intake manifold? The way this works is at atmospheric pressure, you saw it before, it's about 38, 39 psi. As the vacuum increases in the intake manifold, like a normally aspirated engine, the more vacuum, the less fuel you need because the engine is not pulling much air through the system. That's why it has a vacuum. Under boost, you've got more air going into the cylinders than it would be a normally aspirated. So in that case, we actually want to be able to flow higher pressure fuel, more fuel into the injectors to compensate for the additional air from the boost. So we're going to test it both ways. We're going to pull a vacuum and we're going to apply pressure. So let's start with that, okay? We're going to start with vacuum. Go ahead and hook up to that thing. Okay, so how are we looking on the pressure there?
40.
Okay, here we go. We're going to apply, I'm going to pull it down to normal idle vacuum, which is right about there. Where are we now?
30.
About 30. Okay, that's perfect. Okay, so now we will go back to no vacuum, and now we're going to actually apply pressure. I'm doing that with a bicycle pump. The first thing you saw was just a standard vacuum hand pump. Now I'm using a vacuum pump. You see that? And we're actually going to put pressure into this. And I'm going to just, here we go. Oop. Can you see it going up, the fuel pressure? So that's me applying boost, if you will. I'm probably about 7 pounds there. I can't quite read this that well, but so we know that the fuel pressure regulator is bidirectional. That is, it increases the pressure when there's boost air, and it decreases the pressure when the intake is under vacuum, which tells us that the fuel pressure regulator is actually doing what it's supposed to do. Very good. Okay. Awesome. And we can even see that the injectors are no longer leaking because it's holding a pretty decent pressure there. If those injectors were leaking, that thing would drop down real fast. And I'm not going to pop an injector just to watch so it drop because I don't really want to flood the cylinder with fuel again and dilute the gas any more than it has to be. But that's it for today. Just wanted to show you that process. The next step is going to be to install the ignition switch so I can activate the starter, install the coil, and I think I mentioned this already. The coil is activated by a transistor that's fired by the ECU. That's going to take a little bit more work than the standalone igniter that I had on the normally aspirated, but you know, it is what it is. You gotta deal with what you got. But I really like the way that pressure's holding. That's very good. That means I think we've resolved the leaking ejector. I have no idea when it happened. Thanks for watching. Bye.